This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 1, Shafts, Keys, and Power. Power transmission opens on the part that ties the whole machine together, the rotating shaft. A motor delivers horsepower at some speed, and that pair fixes the torque the shaft carries, the single load that every gear, pulley, and coupling downstream has to live with. We turn that torque into a force on a key, size the key in 2 ways, and then check the shaft itself. Get the torque-power relation right, and the rest of this week is built on it. Concept 1. The shaft is the power spine. A drive delivers horsepower at a speed, and that pair fixes one number, the torque. That same torque runs the length of the shaft, so every gear, sheave, and coupling on it feels the same load. A key carries that torque from shaft to hub, and it's deliberately the weak link, sized to shear off first and save the expensive shaft and gear. It's the mechanical fuse. 2 questions decide every part. Can it take one peak load, and can it take millions of cycles? Static versus fatigue. The torsion relation from week 1 is the foundation we build on. Concept 2. Power, torque, and speed. The handbook prints power 3 ways. The rotary US form gives horsepower as torque times speed over 63,025. Rearrange it, and you have the torque directly. The linear form is force times velocity over 33,000, and the SI form is simply force times velocity in watts. The rotary relation is the one you'll reach for all week. It delivers the torque that the gear and belt lessons use as their starting load. Concept 3. The solid shaft under a single peak load. Bending, axial force, and torque don't act alone. The handbook combines them into 2 stresses. The maximum shear form and the von Mises form look almost alike, but 2 things differ. The torque term is 8 times T squared in the shear stress and 48 times T squared in the von Mises. And the leading fraction is 2 over pi times d cubed versus 4 over pi times d cubed. Copy them apart carefully, and note that F here is the axial load on the shaft, not the key force we're about to compute. Concept 4. Fatigue. When the shaft turns for millions of cycles, static strength isn't enough. The handbook joins the maximum shear theory to the Soderberg line, and the whole relation turns on how you pair the terms. The mean moment and mean torque divide by the yield strength. The alternating moment and torque each pick up a stress concentration factor and divide by the fatigue limit. Bending uses Kf, torsion uses Kfs. Cross those pairs and the answer is wrong, so read the pairing straight off the printed equation. Concept 5. The key itself. The torque arrives as a tangential force at the shaft surface, so it acts at the radius, not the diameter. F equals T over R, which is 2T over D. Miss that factor of 2, and the key force is half of what it should be. Then a square key is checked 2 ways. In shear, the force spreads across the full width times the length. In bearing, it presses on only half the height times the length. 2 areas, 2 factors of safety, and the smaller one governs the key. Setup. The worked problem. A 50 horsepower motor turning at 900 drives a 2-inch shaft through a 1/2-inch square key. We're given the key length, the key material strengths, a bending moment at the seat, and the shaft yield. The plan is a single chain. Power gives the torque gives the key force and the 2 key checks, and the torque plus the moment gives the shaft stress. Solve. Part 1. The power relation turns 50 horsepower at 900 RPM into a torque of about 3,500. That torque reaches the key as a force at the shaft surface, torque over radius. Also 3,500. Running it as 2T over diameter gives the same number, which confirms you use the radius and not the diameter. Solve. Part 2. In shear, the force is carried across the full width of the key, giving a factor of safety near 7. In bearing, the force presses on only half the key height, so the area is halved, the stress doubles, and the factor of safety drops to 6. Bearing is the tighter check here, so the key is reported at 6. Whichever is smaller governs. Always run both. Solve. Part 3. The shaft. Feed the bending moment and the torque into the von Mises form, with the axial load 0, and the combined stress comes out near 4,600. Against a 60 ksi yield, that's a factor of safety around 13. So the shaft is comfortably safe while the key sits at 6, and that gap is the point. The key is meant to give way first and protect a far more expensive shaft and gear. Traps. 5 ways this bites. 1. The power constant. 63,025 is for inch-pounds. In foot-pounds, it's 5,252, and swapping them is a 12-to-1 blunder. 2. Taking the key force off the diameter instead of the radius. That halves the force and flatters your safety factor. 3. Bearing on the full key height instead of half. 4. Crossing the Soderberg pairs. Mean terms go with yield. Alternating terms carry the stress concentration factor and go with the fatigue limit. 5. Mixing the two static forms. The shear stress and the von Mises differ in both the torque term and the leading fraction. Quick recall. Power fixes the torque through the rotary relation. That torque becomes a key force at the radius, T over R. Check the key in shear across the full width and in bearing on half the height, and take the smaller factor of safety. For the shaft, combine bending and torque with the von Mises form for a single peak load, or the Soderberg relation for fatigue. Golden rule. Power fixes T, the key force is T over R, and the smaller key factor of safety governs. Next up, Lesson 2, Bearings, Life and Selection. The shaft now has a size torque and a checked key, but it still has to turn in its supports. Bearings don't fail on a single stress. They wear out on a load versus life curve. Lesson 2 builds the dynamic load rating, the load life exponent, and the L10 rating life relation that sizes a bearing for a target number of revolutions. Everything's at PEPrepEngine.com. Cheat sheet, worked solution, and a quiz attached here. If the course helps, subscribe.
The full study guide, with every equation and common exam trap, is free at PEPrepEngine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.